When you're flying with an ADF that has a rotatable card, it can get to be a real pain having to remember to rotate that card every time you make a turn. Now, wouldn't it be nice if that were done for you automatically? Well, that's exactly what you find in airplanes that have an instrument called a radiomagnetic indicator, or RMI. A radiomagnetic indicator has a compass card that works just like your heading indicator. Instead of manually resetting the card every time you turn, it rotates with your heading changes. And like an HSI, if you have an RMI, it's usually slaved to a remote compass, so you don't have to worry about resetting it for precession. An RMI will often have two needles, one thin and one thick, and that's so you can see information from two stations at the same time. It's pretty neat. The needles behave just like ADF needles, but they can be connected to either a VOR receiver or an ADF receiver. And you use the knobs down here at the bottom to select the nav systems you want displayed. On this indicator, the lower left knob can be switched between VOR number 1 and ADF number 1, while the lower right knob can be switched between number 2 VOR and number 2 ADF. Regardless of whether you're working with an ADF or a VOR station, these needles simply point to the station, just like what you see with a regular ADF needle. The head of the RMI needle tells you the magnetic bearing to the selected ADF or VOR station. Conversely, the tail of the needle tells you the magnetic bearing from an NDB you're on. Now, let's see if we can interpret some RMIs and figure out exactly where we are. The two needles on this RMI are both tuned to VORs. The number 1 VOR is tuned to the Livingston Vortac on 116.1 megahertz, and the number 2 VOR is tuned to the Bozeman VOR DME on 112.2 megahertz. Now, if you look at the chart, here are your frequencies for Livingston and Bozeman. And let's assume that you're southeastbound on Victor 86 between Bozeman and Livingston, and ATC gives you vectors around slower traffic. Well, lucky you. But you might want to know where you are in relation to this airway in case ATC asks you to return to it. And you could quickly tell that by looking at this RMI. The tail of the double needle, tuned to Bozeman, indicates you are located on the 102 radial. Now, the airway going southeast out of Bozeman is the 110 radial. See it right here? Therefore, if you're flying in this direction, you are left or east of the Bozeman 110 radial. The tail of the single needle indicates that you are located on the Livingston 239 radial. The airway radial from Livingston is 246, and that means you are south of the airway. If you draw lines from these two nav aids, where they intersect is where you are, right about here, south and east of the VOR changeover point. Now, here's a way to use an RMI to estimate your distance and time it would take you to fly to a nav aid. Some might call it a poor man's DME. First, turn so that the station is almost directly off your wingtip, then fly that heading while timing how long it takes to cross a specific number of VOR radials or degrees of NDB bearing. Then use this formula. Time to the station equals 60 times the number of minutes flown divided by the number of degrees of bearing change. So, for example, let's say it took you 1.5 minutes to make a 5-degree bearing change. Well, 1.5 times 60 equals 90, and 90 divided by 5, your degrees of bearing change, equals 18 minutes. And like all good pilots, you always know your true airspeed. So let's say in this case your true airspeed is 95 knots. Then grab your ever-handy flight computer and figure out that 18 minutes at a true airspeed of 95 knots gives you 28.5 nautical miles to the station. So what if it's not very fancy? It works pretty darn well. And as you can see, an RMI is a great tool for figuring out where you are. Lots of pilots refer to this as situational awareness. And in the clouds, situational awareness is a very important thing.